Virtual day number 22, Math 3, Unit 6, Day 2, April 20th. Angles and circles. So this is technically day 1 because we're not doing day 2 because of the craziness. I'm cutting out what I can. So we're going to cut out day 1 and we're going to start with day 2 for this unit. We're working on circles and angles within circles, angles outside of circles, segments of circles, chords, arcs, tangents, all kinds of awesome things like that. So start with some definitions. Circle is a set of all points in a plane that are equidistant from a given point, called the center of a circle. So the circle looks like this. This is your center. All the points on this circle are equidistant from the center. That's what the radius is. So the radius is the distance or the segment from your center to any point on your circle. A chord is a segment whose endpoints are on the circle, but not necessarily through the center. So this would be an example of a chord. A diameter is a segment with endpoints on the circle that contains the center, so it has to go through the center there. That is a diameter. Diameter is twice the radius. A secant is a line that's like a chord. It's like if you extended the endpoints on a chord, going to go through 2 points of your circle. That's a secant. Goes through your circle twice. A tangent is a line that touches your circle in one place. So in one place, let me scoot still a little bit. Sorry, put the fuzziness there. Like this. And then the point of tangency is just the point where your line touches your circle. Okay, so now we're going to use these definitions and look at example 1. Tell whether the line or segment is best described as a chord, secant, tangent, diameter, or radius. So AD, because we're just talking about that segment, AD, that is a diameter because it contains the center of your circle. CD is a radius. EG is a tangent line. HB is a chord. FB goes like this around your circle. That's the connection between F and B. That is called an arc, which is just a piece of a circle. And FE is a tangent again. Let's see, we didn't talk about a secant, which would be, so DK would be a secant. And the point of tangency, I think, is the only other thing. We did a chord, a radius. So the point of tangency, F, would be a point of tangency. And I think that covers everything on this. So those words. Now we're going to look at some formulas with angles of circles. So we're starting first with an inscribed angle. An inscribed angle is an angle with the vertices and endpoints of the angle on your circle. So inscribed angle touches in all places of your circle. Okay, so if the vertex is on the circle and the endpoints of the angle are on your circle. This is just fancy notation for arc AC. It's like a little miniature A on top of the A there, on top of your first letter, arc AC. And AC is an intersected arc. Intersected means it's intersected by this angle. It's the arc that's created by that inscribed angle. So the measure of this angle is half the measure of this arc in degrees. One circle is 360 degrees, so this is going to be a portion of that 360, and this angle is going to be half of that arc measurement. If they intercept the same arc, so if you have two, so you have one here, and then you have this one here, both of those intercept the same arc AC. You could also look at it this way, and they intercept BD, so BD or AC, and that means the angles are congruent. And if an inscribed angle subtends a semicircle, so that means if the line between the endpoints there goes through the center, then it's a 90-degree angle because this would be 180 degrees. So since this inscribed angle is half of that, it's going to be half of 180, which is a 90-degree angle. So we're just going to use this to find the measure. The measure of angle LMP, so that's this angle, and the measure of arc MN. So that arc and this angle. This angle is 36 degrees. So the angle LMP is going to be half of arc LP. Now it's just like a tiny little A on top. Arc LP. Arc LP is 36 degrees. So angle LMP is going to be half of 36. Which means that angle LMP is going to be 18 degrees. Arc MN, so again, we're looking at the same situation. Angle MPN is half of that arc. Arc MN. We know the angle this time, so we have 46 degrees here is going to be half of arc MN. To undo multiplication by a fraction, multiply both sides by the reciprocal. So multiply both sides by 2/1. And you get arc MN is going to be 92 degrees. Looking at the same thing with number 2. We want to find the measure of angle GFJ. GFJ is this angle here. And we want to find arc FH now. FH. So GFJ is going to, it subtends this arc here. So I'm just going to dash line. You can see that. Dash line there. So GJ is the arc with the angle GFJ. So GFJ is going to be half that measure of this arc. So angle GFJ is half of arc GJ. Arc GJ, it tells you is 110. So angle GFJ is going to be 55 degrees. And then arc FH deals with the angle FJH. So angle FJH is going to be half of that arc FH, which we don't know, but we know the angle FJH is 36 degrees. Multiply both sides by 2/1, and you get the measure of arc FH is going to be 72 degrees. Find each value, so the value of x. So because this inscribed angle, the line between the arc there tends through the center, that makes that a diameter, which means that this arc right here, you could say this arc is 180 degrees, or because it goes through the diameter, this has to be a right angle. So you could look at it either way. Look at it the way we looked at it up here. This angle has to be half of that 180. Or you could say this angle has to be 90, which either way works out. So 5x plus 8 is 90 degrees. 8. 5x equals 82. Divide both sides by 5. You get x equals 16.4. The next one we're going to find, this one says find the measure of FJH. So in order to find that, we have to find Z. Well, we've got two inscribed angles here with no measurements, But because both of these angles here, FGH and HJF, subtend the same arc right here. Okay, so they intersect the same arc, FH, and that means this angle and this angle have to be congruent. So we can set up that equation. 5z equals 4z plus 9. Get your z's together. You get z equals 9. But be careful because it's asking you for the measure of angle FJH, so I'm plugging that back in. Measure of angle FJH equals 5z, so 5 times 9, which is 45 degrees. Okay. Now we're going to look at a tangent and a secant, two tangents and two secants, and the angles created. So the measure of angle 1, this is created by a tangent, which is CD, and a secant, which is AC, is going to be half the difference of the bigger arc, which is AD, created here, minus the smaller arc, okay, which is BD. So half the big arc minus the small arc. Same situation with two tangents. It's half of the bigger arc, which is EHG, and the smaller arc, which is EG. And then this one is the same, half of the big arc minus the small arc. So here's an example of that, and then we're going to do some example problems. So to find the value of x, and that's all we're doing for each of these. This is a tangent and a secant. X is going to be half the big arc minus the small arc. So x equals 1/2 of our bigger arc, which is 140, minus our small arc, which is 74. 140 minus 74 is 66. So our angle x is going to be 33 degrees. With number 6, this one only gives us one arc measurement, but because it's two tangents, those two things together have to be 360. So to find this arc measure, you're saying 360, because that's a whole circle, minus your bigger arc, which is given to you, 232. So that's going to be 128. And now we can say that x, so this is 128, is half the big arc minus the small arc. Half 232 minus 128, half of 104, 52 degrees. This one we have two secants, but it follows the same rule. X is going to be half the big arc, which is 75 degrees, minus the small arc, which is 29 degrees. So you have half of 46, which is 23 degrees. The last one involves a little bit more math. Our outside angle, which is 35 degrees, is going to be half the big arc minus the small arc. So we're setting up the equation the same way. Our x is just measurement spot. So we have 35 is half the big arc, which is 106, minus the small arc, which is what we don't know. You can distribute your 1/2. 35 equals 50. Oh, I'm sorry, that's 108, not 106. I think it's 108. Half of 54 minus 1/2 of x, or half of 108, which is 54 minus half x, so we'll just distribute it there. Get our constants together. We'll subtract 54 from both sides. Negative 19 equals negative 1/2 x. To undo multiplication by a fraction, multiply both sides by the reciprocal. And you get x equals 38 degrees. We are nearly done. Inscribed angle and an intercepted arc. We've looked at both of these things. This is your inscribed angle. And this right here is your intercepted arc. Sorry. The measure of an inscribed angle is half the measure of an intercepted arc. This right here, angle ACB, is a central angle, which means its vertex is at the center point. And it is equal to the arc measure. So the measure of angle ACB is equal to the measure of arc AB. Which means this one is, or ADB is half of the central angle as well. So that's the only other thing we're looking at today is a central angle. So this is a diameter, it's the diameter there, this one is not, and this one is not. Let's look here. It gives you that this is a right angle. Find the measure of each arc and inscribed angle. So that's a 90-degree angle. The measure of angle SRQ is 90 degrees because it's marked so that it tells you that it's 90, it's a right angle. So half the measure of the arc is equal to your angle. So the measure of angle SRQ is equal to half the measure of arc STQ. We know that SRQ is 90 degrees. Undo multiplication by a fraction. And you can say the measure of arc STQ is going to be 180 degrees. The next one, again, the measure of this angle is half the measure of its arc. So the measure of angle ZYX is going to be half the measure of arc ZWX. Now, if I had said arc ZYX, that would make this arc. So be careful on the letters that you use. We know the angle measure is 115. Multiply both sides by 2. And you get the measure of arc ZWX is equal to 230. Same situation over here. The measure of angle NMP is half the measure of arc NP. Well, we know that our arc is 100 degrees. Pretty sure this is 100. So the measure of angle NMP is 50 degrees. Two more. This one we want to know the measure of angle BAC. Okay, so again, this is a central angle. So because it's a central angle, it's equal to the arc. So you can say the central angle, or this angle is half of the central angle, or it's half of the arc. Either way it works. The measure of angle BAC is going to be half of your 132, which is 66 degrees. And then our last one, the measure of angle BAC. So that's this angle. Well, we know this central angle is 94. BD is a diameter. So because it's a diameter, these two angles here, BOC and COD, are supplementary. So the measure of angle BOC is going to be 180 minus 94 because they are supplementary, which is 86 degrees. So now because this is a central angle, that is the same as this arc that intercepts this arc. That arc is 86 degrees. So the measure of angle BAC is going to be half of that arc, which is 86. So BAC is going to be 43 degrees.